An AI training job keeps failing. GPUs are underutilized, networking latency is unpredictable, and storage throughput becomes the bottleneck. The model isn't the problem, the infrastructure is. Modern AI workloads demand more than compute power. They require the right balance of GPU architecture, high-speed networking, scalable storage, and orchestration. That's exactly what the NVIDIA Certified Professional AI Infrastructure exam is designed to validate. This certification confirms your ability to design, deploy, and operate AI infrastructure using technologies from NVIDIA, with a focus on performance, reliability, and scalability. In this video, we'll work through practice questions that begin with real AI infrastructure challenges and guide you toward the most effective architectural decisions. Let's step into the role of the AI infrastructure professional. Question number 1. A systems administrator is preparing a new DGX server for deployment. What is the most secure approach to configuring the BMC port during initial setup? A. Enable remote access to the BMC over the internet using the default admin credentials for initial troubleshooting. B. Connect the BMC port directly to the production network and retain default admin credentials for convenience. C. Leave the BMC port disconnected until after the operating system is fully configured and in production. D. Connect the BMC port to a dedicated and firewalled network and change the default admin credentials. Answer D. Connect the BMC port to a dedicated and firewalled network and change the default admin credentials. Explanation. The correct answer is option D, secure isolated BMC configuration with proper access control. The Baseboard Management Controller, BMC, provides deep hardware-level control, power cycling, firmware updates, remote console, so it is highly sensitive. Because of this, it must be protected using a dedicated out-of-band OOB management network, isolated from both public and production networks. Exposing it directly, option A or B, creates serious security risks, and leaving it disconnected, option C, is impractical for operations. Security best practice requires network isolation plus strong credential management, removing default credentials and enforcing secure access. This ensures secure remote management while preventing unauthorized access or lateral movement in the environment. Question number 2. An engineer needs to verify NVLink isolation on a single node with 8 GPUs. Which NCCL test configuration stresses switch bisection bandwidth? A. Use NCCL test split div 8 with point-to-point tests. B. Use all reduce perf B8, E16G, F2, G8 with NCCL test split and 0x1. C. Use reduce scatter perf B8, E16G, F2, G4. D. Use all reduce perf B8, E16G, F2, G8. Answer. B. Use all reduce perf B8, E16G, F2, G8 with NCCL tests split and 0x1. Explanation. To validate the robustness of the NVLink switch fabric in a DGX H100, engineers must test how the switches handle traffic when the cluster is logically partitioned. While a standard all-reduce perf test, option D, shows aggregate throughput, it may not reveal issues with specific internal switch paths. Using the NCCL test split environment variable allows for more granular stress testing. Specifically, using a bitwise mask like AND0x1, option B, creates specific traffic subsets that force data through the internal NVLink switch bisection. This ensures that even when only half the GPUs are communicating, or when specific patterns are used, the switches can maintain full wire speed without internal contention. This is a critical validation step during the bring-up phase to ensure there are no manufacturing defects in the NV switch baseboard or the high-speed traces connecting the GPU modules. Question number 3. ClusterKit's NCCL bandwidth test shows 350 GB per second on a 400G InfiniBand fabric. How should this result be interpreted? A. Optimal performance. indicating healthy fabric and GPU direct RDMA. B. Suboptimal performance, requires FEC tuning to reach 380 plus gigabytes per second. C. Critical failure, expected is 390 gigabytes per second for HDR InfiniBand. D. Inconclusive, rerun with dash stress equals CPU to validate. Answer A. Optimal performance, indicating healthy fabric and GPU direct RDMA. Explanation. Interpreting NCCL, NVIDIA Collective Communications Library results, requires understanding the difference between theoretical link rate and effective bus bandwidth. A 400G NDR InfiniBand link has a theoretical unidirectional capacity of 50 gigabytes per second. In an 8-GPU DGX system, where each GPU is typically mapped to its own 400G HCA, the aggregate theoretical bandwidth is 400 gigabytes per second. However, NCCL performance benchmarks report bus bandwidth, which accounts for the mathematical overhead of collective operations like all reduce. Achieving 350 gigabytes per second, option A, is widely considered optimal and representative of a healthy, well-configured fabric. This indicates that the system is effectively utilizing GPU direct RDMA to bypass host memory, and that the network switches are routing traffic without significant congestion or packet drops. Expecting 390 gigabytes per second, option C, is unrealistic once protocol headers and algorithmic overhead are subtracted from the raw bitrate. Rerunning with CPU stress, option D, would not provide insights into the InfiniBand GPU fabric health. Question number 4. An InfiniBand administrator needs to run performance benchmarks on new devices added to the fabric. What tool should be used to check the latency? A. TCP dump, B. IB write-lat, C. IB diagnate, D. perfmon. Answer B. IB write-lat. Explanation. While the InfiniBand fabric is known for high bandwidth, its defining characteristic for AI workloads is ultra-low sub-microsecond latency. When new nodes or switches are added, administrators must verify that the point-to-point latency meets the hardware specifications. The IB write-lat utility is the standard micro-benchmark from the PerfTest suite used for this purpose. It measures the time it takes to complete an RDMA write operation between two nodes. This tool is verified because it operates directly over the InfiniBand verbs layer, bypassing the CPU overhead of the standard TCP/IP stack. Unlike TCP dump, option A, which is used for packet capture, or IB diagnate, option C, which is used for fabric-wide discovery and error reporting, IB write-lat provides a granular nanosecond-level measurement of the link's responsiveness. In an AI cluster, even a small increase in latency can cause a straggler effect in distributed training, where all GPUs wait for the slowest link to complete a synchronization step. Question number 5. A network engineer is tasked with configuring the management, storage, and compute networks for a new DGX base pod deployment. Which statement best describes the network segmentation required for optimal operation? A. A single VLAN for all types of network traffic. B. 2 networks, one for management and one for compute. C. 4 networks, compute, storage, out-of-band, and management. Answer C. 4 networks, compute, storage, out-of-band, and management. Explanation. The correct answer is the 4-network segmented architecture: compute, storage, management, and out-of-band networks. NVIDIA DGX BasePod and SuperPod designs enforce strict network separation to ensure performance and reliability. Each network has a dedicated role and avoids traffic interference between workloads and administration. Compute network, high-speed InfiniBand Spectrum-X for GPU to GPU communication. Storage network handles data transfer and checkpoints, e.g. GPU direct storage. Management network, used for cluster administration and orchestration. Out-of-band OOB network, dedicated to BMC-level hardware control and monitoring. A single VLAN is not acceptable because it creates congestion and risks performance degradation. This separation ensures scalability, fault isolation, and uninterrupted AI cluster operations. The NVIDIA Certified Professional AI Infrastructure exam is about building systems that AI can rely on. Each practice question strengthens your ability to diagnose performance constraints, select the right GPU, networking, and storage architecture, and design infrastructure that supports demanding AI workloads at scale. The more scenario-based questions you work through, the more confident you'll become in making infrastructure decisions that maximize AI performance. If you're looking for more NVIDIA AI infrastructure practice questions, check the link in the description for additional resources available on CertBoosters. Subscribe to the channel for more AI, GPU, and infrastructure certification practice sessions. Thanks for watching, and remember, powerful models need powerful infrastructure to succeed.